Welcome back to another explainer. Today, we're taking a comprehensive deep dive into something that's honestly completely rethinking how developers interact with infrastructure. Look, if you've ever had to file an IT ticket just for a simple routing rule change, waited 3 days for it to be processed, and then realized you made a typo, yeah, you know the exact pain and friction of traditional load balancing. Well, our goal today is to demystify high-performance routing by unpacking a platform called Ruvamco. It's built to basically permanently bridge that gap between complex infrastructure and developer ease. I am absolutely thrilled to get into this with you, so let's get started.
So, what exactly is Ruvamco? At its core, it's a production-grade, self-service edge proxy platform. It lets developers provision load balancing, edge routing, auth, and more, all through incredibly simple configuration files. To really get why this matters, you kind of have to understand that raw Envoy proxy is an absolute beast. I mean, it's incredibly powerful, but it is notoriously complex to configure manually. Ruvamco fixes that. I really want to hit hard on those two words, self-service and simple. This isn't about submitting a ticket and waiting. This puts the power directly back into the hands of the engineers who are actually writing the application code.
Okay, let's dive into this roadmap. We're going to meet the Ruvamco Edge proxy, explore its high-performance features, decode the architecture, dive into some real-world performance metrics, and finish up with a super-fast developer quick start.
Section 1. Meet Ruvamco Edge Proxy.
Section 2. High-performance features.
So, Ruvamco was really born out of a specific need in modern cloud-native environments. It takes the sheer raw power of an Envoy Edge proxy and wraps it in this beautiful, developer-friendly workflow. And that gives us this incredibly robust feature set. Right off the bat, it's multi-cloud ready, so you're deploying seamlessly across AWS, GCP, or Azure. It uses extensible sidecars for things like pluggable auth and rate limiting. You've got built-in observability out of the box with Prometheus and Grafana, a dedicated developer CLI, and, this is huge, it runs on async operations, meaning your CI/CD pipeline doesn't have to hang for 5 minutes just waiting for a routing update status.
But the real game changer is the self-service provisioning. Developers just declare their routing in simple YAML. Imagine going from managing a massive 1,000-line Lewis script to just typing timeout 5s in YAML. That's literally what Ruvamco is doing here. You define your domain, your backend target, your rate limits, all in a few highly readable lines, and the platform automates the complex Envoy configs behind the scenes. It completely removes the infrastructure bottleneck.
But hold on, that brings up a pretty massive real-world question. If developers are constantly pushing new YAML configs, how on earth does Ruvamco handle those updates without dropping live traffic? In a high-throughput environment, you absolutely cannot afford to bounce your proxy every single time a route changes.
Well, the secret sauce here is dynamic configuration. Ruvamco leverages Envoy's dynamic config APIs to push these updates in real time. That means 0 restarts. None. When a developer provisions a new route or updates an auth rule, it happens instantly. This is the key to true continuous deployment with absolute 0 downtime.
Section 3. Decoding the architecture.
Let's look at a day in the life of a developer workflow here. Step 1. You write a simple YAML config file, maybe defining an API route that needs a specific JSON web token. Step 2. Standard Git push. Step 3, Ruvamco's automated systems take over, and that route is auto-provisioned in less than 30 seconds. 30 seconds! That tedious, agonizing process of infrastructure adjustment is basically instant now. But what's actually happening in those 30 seconds?
It's all about the brain versus the muscle. This is how Ruvamco separates its concerns. The control plane is the brain. That's your broker API, your async workers pulling from a queue, and your state database. That database is absolutely critical because it's the source of truth for what the system intends to do before it commands the muscle. And the data plane? That's the muscle. This is the physical pathway for the user's traffic, flowing from a CDN, through a network load balancer, and hitting an auto-scaling Envoy proxy fleet. The brain tells the muscle exactly how to handle that massive wave of traffic.
Now, the data plane's muscle isn't just routing blindly. It's enhanced by these pluggable sidecars that sit right alongside the Envoy proxy fleet. By decoupling functions into sidecars, you get pluggable authentication, sophisticated rate limiting, and deep observability. And the security win here is massive. Moving authentication into a pluggable sidecar means your security protocols and updates can happen totally independently of your core routing logic. For enterprise architecture, that is a huge win.
Section 4. Real-world performance metrics.
Over 1 million. Want that sink in? That is the staggering request throughput.
1 million plus requests per second that Ruvamco handles. To put that into perspective, that's the kind of massive traffic spike you'd see during a huge live streaming event or a colossal Black Friday retail rush. It is built for absolute internet-scale traffic.
And then there's this number, 99.999%. 5 nines. While the control plane, the brain, targets a very solid 4 nines of uptime, this 5 nines figure is the data plane uptime target. It proves the sheer, unbelievable reliability of the muscle. Even if the control plane temporarily blips and you can't push a new config, your existing data plane fleet is just going to relentlessly continue routing traffic with 5 nines of reliability.
When you look at the full metrics, this scale is just wild. We're talking a proxy fleet size of over 2,000 instances, supporting more than 10,000 backend services. But check out that config propagation time, under 5 seconds. Think back to the developer pain points we started with. Under 5-second propagation means when you hit push on a critical hotfix, it is live globally almost instantly.
To pull this off, the project uses a very intentional tech stack. It leans heavily on Python, which makes up over 56% of the codebase. Why Python? Because using frameworks like FastAPI and Pydantic gives you this perfect blend of rapid development and the high I/O performance you absolutely need for an async broker API. And of course, infrastructure as code is a first-class citizen, with Terraform's HCL making up 15% to seamlessly manage those multi-cloud deployments.
Section 5. Developer Quick Start.
The absolute best part of this architecture is how low the barrier to entry is. You probably have the prerequisites on your laptop right now. You just need Docker and Docker Compose, Python 3.11 or higher, the AWS CLI if you're going to the cloud, and Terraform 1.5+.
Once you've got those, it's honestly magic how fast this spins up. What used to take a dedicated ops engineer and a staging server now happens right on your local machine. You literally just git clone the repo and run makeup. That uses Docker Compose to instantly orchestrate the control plane and a local Envoy instance. From there, you use the developer CLI to run Ruvamco apply against a basic YAML config. You can check your routing status with Ruvamco list, watch the logs with Ruvamco logs, and when you're done playing around, just hit make down. It is an incredibly frictionless, satisfying experience.
Which leaves us with one final thought. Are you ready to stop waiting on infrastructure tickets and actually take control of your edge routing? If you found this architecture as fascinating as we do, head over to GitHub, give Ruvamco a star, clone the repo, and start provisioning today. The era of self-service, high-performance edge proxies is absolutely here, and it's built to empower you. Thanks so much for joining me on this explainer, and we will catch you in the next one.